So Silverthread's technology is based on research that had been done at MIT and Harvard over the course of about 15 years. Professor Alan McCormack and Carlos Baldwin had developed ways of measuring the technical health of software systems and did a variety of research publications on those topics. Later on, when I started working with them, we were statistically connecting those technical health measures to business outcomes, specifically things like how does that relate to defect density or developer productivity? And what does that mean for agility of a software development organization, or risk or waste or cost? Based on the ability to couple a deep understanding of the technical health of software systems and the business impact that it has, we can work with people to bridge the gap between a technical understanding of what you're building and the business implications so that you can make better decisions. So CodeMRI is a technology that we developed originally at MIT and Harvard and now have commercialized. It is a way of measuring the technical health of software systems, both from an architectural standpoint and from a code quality standpoint. We've also done a lot of statistical work linking those measures to business outcomes such as developer productivity and defect density and others. What we can do now is, given a new code base, we can ingest that code into the platform, run it through the predictive models so that we can show you what the economics are of working in the system, as well as give you a detailed understanding of the technical health. We could also tap into someone's version control systems, issue tracking systems, other management systems to calibrate those models instead of having predictive models if they want to make more refined adjustments to the policies that they have internally. CodeMRI also contains technologies that help people fix systems. That's been developed more recently, but we've developed tools to give people perceptiveness into the technical health of the system, be able to set controls and rules so that they prevent new problems and identify the best thing to do in the system to break apart existing problems. So people have used this to prevent issues and then go on a path where they are improving both their technical health and the economics of their organization and measuring both along the way. One example of an impact we had was an organization that we've worked with recently that had a 2,000 file Java codebase that had been around for about a decade. It was in reasonable shape, but it had definitely developed some challenges. We did predictive analytics that showed the amount of waste and cost and risk associated with future development in that codebase. Based on our combined assessment of both the technical architecture and of the economic implications, that team was able to make the business case within their organization to get funding to pay down that technical debt. They were then, over the course of about 4 months, able to spend 25% of their development labor attacking the health issues in that codebase, completely eliminated them. And when we did the assessment after the fact, we found that they had become 3 times as productive as a team.